So this is different from the rule that I gave last class, the remainder theorem. If a function f of x is given and is divided by ax minus b, then f of b on a is equal to the remainder. So you might be wondering, where exactly did they get b on a? Well, when we were doing remainder theorem last class, I told you the first thing you want to do is to make the divisor equal to 0. This right here, this would be your divisor. And the first thing you want to do when doing the remainder theorem is put it equal to 0 to solve the value of x. That's how they went from f of x to f of b on a. If I have ax minus b, if I'm given that as my divisor, and I told you that the first step is to put the divisor equal to 0 to solve for x. So ax minus b, that's my divisor, I put it equal to 0 to solve for the value of x. If I transpose just means to make something subject of the formula. If I transpose to make x subject of the formula, I would get b divided by a. And that's how they got b on a, right? So f of x, what they did, since we know that the value of x is b on a, instead of writing x, what they did was that they wrote b on a. And that would give you your remainder. Remember that, right?
Yes, please.
Okay. Similarly, if you're given a divisor in the form ax plus b, so I'm telling you now, the divisors would always look like this. Ax minus b or ax plus b. That's the form they would give you, right? It's called linear form. It would always look like that. And that's why you could follow the rules. If you given it in the form ax minus b, so say your divisor for a particular question was 2x minus 1. What I'm telling you is that the remainder is f of b on a. B, in this case, would be 1, and then a is 2. So what I would have, if I'm trying to find the remainder of that particular function, I would have f of a half, right? So these rules would always apply because your divisors would always be in this form. So like I was saying, similarly, if you had ax plus b, the remainder would be f of minus b on a. How did they get minus b on a? They put the divisor equal to 0 and solve for the value of x. When they found the value of x, instead of putting x here, they replace the x with minus b on a. F of minus b on a, whatever value I get, when I substitute that x value into my polynomial expression, that would give me my remainder. That's what we did last class, right? This was an example. What is the remainder when g of x, so this is the function that they gave us, is equal to 2x cubed plus 4x squared plus 3x minus 1, and they told us that it's divided by x plus 1. So x plus 1 is my divisor. In this case, it's understood that the value of a is 1, right? They asked me for the remainder. So the first thing you want to do, put this equal to 0, solve for the value of x, and then sub in the value of x into the function. Or you can just look at this rule and you say, okay, they told me that my divisor is x plus 1. X plus 1, that's in this form. And according to the rule, if it's divided by a divisor that's in this form, ax plus b, then my remainder is going to be f of minus b on a. In this case, the b that they're referring to is 1, and a is 1. So what does that mean? That means that my remainder is f of minus 1. Well, g of minus 1. This real quick. According to my rule, if the divisor is in the form ax plus b, in this case it is in the form ax plus b, because my divisor is x plus 1. It's understood that the value of a is 1. According to my rule, if the divisor is in that form, then the remainder is f of minus b on a. But of course, you won't use f in this case. Why? Because they told you the function is g of x. So to find the remainder in this case, it would be not f of minus b on a, but g of minus b on a. B is 1, so minus 1 divided by a, and a is 1, would give me my remainder. Minus 1 divided by 1 is 1. So g of minus 1 is going to give me my remainder. But how exactly do we find the remainder? Well, that's for the second step on it. That value of x that you got, you're going to sub it into the function. What do I mean by sub it into the function? Well, you see that value of x that you got in the first step? So we got x is minus 1. What you're going to do is put that value of x into the polynomial expression. So this is the function it gave me, 2x cubed plus 4x squared plus 3x minus 1. Instead of putting back the x, what I'm going to do is replace it with minus 1. So this becomes g of minus 1, because my x value is now minus 1, would be 2 minus 1 cubed plus 4 minus 1 squared plus 3 minus 1 minus 1. And I told you whatever answer you get here, this is your remainder. When I do all this, the answer I get is minus 2. So I have here, recall. Okay, I'll change that. That was from the rule from before. So this is supposed to be b on, well, in this case, it's minus b on a. So f of minus b on a gives me the remainder. We found out that, well, in this case, it's g, right? G of minus b on a was g of minus 1. And then I told you when you substitute that value of x into your function, whatever answer you get, that's your remainder. That's why I have down here, g of minus 1 is equal to minus 2. Therefore, this minus 2 is my remainder. You good with that?
Yes, miss.
Okay. Factor theorem. Like I said, we did all the past papers. You could just write down these years, right? Just tell me when you finish. We did them in class last.
Yes, miss, I'm finished.
Oh, okay. Factor theorem now. So what exactly is the factor theorem? Well, it's very similar to the remainder theorem. The factor theorem tells me if f of b on a is equal to 0, or f of minus b on a is equal to 0, then the divisor, whatever divisor they gave me, is a factor. So what does this whole rule mean? In simple language, with all these symbols. If I get a remainder that's equal to 0, that means that my divisor is a factor. If it's not equal to 0, it's not a factor. But if the remainder is equal to 0, then it is a factor. So before we get into the whole polynomial expressions, let's start off with something we already know. So if I said 128 divided by 2, right? We already know that 2 is a factor of 128. But how come 2 is a factor of 128? Well, you would say 2 divides 128 without a remainder. In other words, 2 divides 128 and gives a remainder of 0. That's why we say 2 is a factor of 128. So let's just do the long division to show you that, right? 2 into 1 is 0, so you wouldn't put that. Then you would say 2 into 12 is 6. 6 times 2 is 12, minus 12, so that's 0. Bring on the 8. Yeah, we already know to do this, right? We just put a 0. And then 2 into 8 is 4. 4 times 2 is 8. 0. So that's how we know that 2 is a factor of 128. Why? Because when it divides 128, my remainder is 0. Or you might say there's no remainder. That's how we know it's a factor. Same concept applies here. If I divide a polynomial expression by a divisor and my remainder is 0, that means that it's a factor of the polynomial. You good so far?
Yes, miss.
Okay. Once you're good with that, we're good to go. Let's do a quick example before we go into the past papers. So that's not Okay. After this example, we go straight into the math papers. Say I am given the function p of x is equal to 8x cubed. Gosh, sorry, that's a trick. Anyways, minus 22x squared minus 7 plus 3. No, 7x plus 3. So this is my polynomial. If I then gave you two divisors, so I told you that the divisors, two of them, if I say I want you to divide this polynomial expression by x plus 3 and 4x minus 1. And what I want you to do, I want you to determine which one of these divisors, x plus 3 or 4x minus 1, is a factor of p of x. Well, we know from just now, if it's a factor, if my divisor is a factor of the polynomial expression, then my remainder would be 0. So they want to determine, is x plus 3 a factor or is 4x minus 1 a factor? We know to do that, we need to find out the remainder. If the remainder is 0, then that means that it's a factor. So let's do that now. So just erasing this, right? So why I said this is similar to the remainder theorem is the steps. It's because the steps are the same. So step number 1, they want me to find out if x plus 3 is a factor. So the first thing you want to do, you put your divisor equal to 0. And then the second step, so by putting divisor equal to 0, you'll get a value of x, right? So x is equal to something. And then the second step is to use this value of x that you got and substitute it into your function. So just put sub. Okay, let's do that now. We are given the divisor x plus 3. The first thing you want to do, put the divisor equal to 0. Equal to 0, that means that my value of x is equal to minus 3. But if you didn't want to do that, like put it equal to 0 and put it equal to 0. You could recall the rule that says, if I'm given a divisor that's in the form ax plus b, then my remainder is f of minus b on a is equal to my remainder, right? So what I'm saying is, instead of writing on paper x plus 3 is equal to 0 and then solving for x, you could just remember this rule and say, okay, if I'm given it in the form ax plus b, then my remainder is f of minus b on a. So you choose. You go on, put it equal to 0 and solve for x, or you could just use this rule, right? And you would still get the same minus 3. Why? B in this case, b is 3, so minus b is minus 3, and then a is 1. So you would still get the minus 3, right? So just to make that clear. So what does this mean? They told me, well, I found out that the value of x is minus 3. So what does that mean? That means that p of minus 3 is going to give me a remainder. What we're trying to figure out is if this remainder is going to give me 0. If it's 0, then it is a factor. If it's not 0, well, it's not a factor. So according to my second step, I have to substitute this value of x into my polynomial expression or the function to find out what the remainder is. So how exactly would we do that? Well, p of minus 3, wherever I see x in this function, Instead of putting x, I'll replace it with minus 3. So 8 minus 3 cubed minus 22 minus 3 squared plus minus 3 squared minus 7 by minus 3 plus 3. Of course, we could simplify this further to find the value of my remainder. Minus 3 cubed, that's minus 27. Hold on, I'm trying to join. Minus 3 cubed, that's minus 27. And minus 27 multiplied by 8, that's minus 216. Minus 3 squared, that's 9. And 9 times minus 22 is going to give me minus 198. Minus 7 times minus 3, that's plus 21. And then we have the plus 3. This obviously will not give me 0, but you know, well, not obviously, actually. Anyways. This obviously will not give me 0, but you still need to show it, right? You still need to finish the calculation, finish simplifying. So the value for this is minus 330. What does this mean? P of minus 3 is minus 390. My bad. So P of minus 3 is equal to minus 390. Therefore, minus 390 is my remainder. Since this remainder is not 0, that means that this, right here, this divisor, x plus 3, that is not a factor of this function p of x. You good with that?
Yes, miss.
Okay, nice. Let's do the other one. So we found out that the divisor x plus 3, that is not a factor. But what about the 4x minus 1? We need to see if that one is a factor. Remember, if it's a factor, then my remainder would be 0. So what we're trying to figure out is if when I use the divisor 4x minus 1, would I get a remainder of 0? Well, let's see. Gosh, it's taking a while. Anyways, so given the divisor of 4x minus 1, and they want us to find out if this divisor is a factor of this polynomial expression. Remember, if it's a factor, the remainder is 0. Okay, so the first step, put this equal to 0, solve for a value of x. X is going to be a quarter. Or you can use the rule that says if I have a divisor that's in the form ax minus b, then my remainder is f of b on a. So you could do this, like actually write it out, divisor equal to 0, solve for the value of x. Or you remember this rule, if I see my divisor in this form ax minus b, then this is my remainder, f of b on a. You get the same answer. How? Well, b in this case would be 1. So that's 1 divided by a, in this case would be 4. So I'll still get the same quarter, right? So that was just to show you that both work. Write on this or remember the rule. Next thing you want to do to find the remainder is substitute that value of x that you got into your function. What do I mean by substitute? Well, wherever I see x in this function, instead of writing x, I'm going to put a quarter. So p of a quarter, whatever value I get, that is my remainder. Our aim is to see if this remainder is going to be equal to 0. If it's 0, then it is a factor.
Yes, miss.
So p
0.
of a quarter, yeah, and therefore it is a factor. But let me just show this for whoever will be watching this recording in the future. But yes, it is a factor. Right. So substitute a quarter into this function. What would you get? Well, p of a quarter is going to give me 8. Instead of putting x, I put a quarter cubed minus 22 a quarter squared minus 7 times a quarter and then plus 3. When I simplify this, my answer would be 0. What does that mean? P of a quarter is equal to 0. 0 is my remainder. So let me just put a box. P of a quarter is my remainder, and we found out that P of a quarter is equal to 0. What does that mean? My remainder is 0. Since my remainder is 0, that means that this divisor, 4x minus 1, is a factor. So just for the people who came in late, I had 2 divisors, and the question wanted you to determine which one of them was a factor. The first one wasn't a factor, but this one is a factor. So you good with that?
Yes, Miss.
Okay. If anybody who came in late is confused, please let me know.
Good afternoon, Miss. Sorry for being late.
Good afternoon, that's fine. All right. So this is what we are doing, right? We just finished factor theory. Well, going through the theory. Now we're going to do past papers. Yay. Gosh, which past paper is that? That's 12, number 1B. Oh wait, hold on. Just for the people who just came in, we said if the remainder is 0, then the divisor is a factor. That's literally what the factor theorem is about. The remainder is 0, it's a factor. So this one, I want you to try it by yourself, and then I'll go through it with you. So they actually told you that this divisor, x plus 2, is a factor of the function, and they want you to find the value of a. So just attempt it for me, and then we will go through it together. Right, so we're given that this x plus 2, so this divisor, is a factor of the function f of x, which is given by 2x cubed plus 2x cubed minus 3x squared minus 4x plus 8. Now what do they want you to do? Well, they want you to find the value of a. But how exactly do we go about doing that? Well, since they told us that this is a factor, I know that if a divisor is a factor, then the remainder is going to give me 0. Factor, so let me just write this out. Factor, therefore, remainder is going to be equal to 0. How do we find? Let me not see that. Well, how do we go about doing that, right? Well, you need to recall the steps. So the step, put your divisor equal to 0. To solve a value of x. So by putting my divisor equal to 0, I'll find the value of x, right? So x is equal to question mark. Second step, this value of x that you got, you're going to sub it into the polynomial expression that they gave you. So what is my value of x in this case? Well, if I put this equal to 0, I'm going to get x is equal to minus 2. What does that mean for me? F of minus 2. So why am I writing it like this? Well, they told us that the function is f of x, but we just found out that the value of x is minus 2. So instead of writing f of x, I can write f of minus 2. And according to them, f of minus 2, when I do that, my remainder is supposed to equal to 0. Hold on now. Okay, sorry about that. Right. According to them, x plus 2 is a factor, right? So if x minus 2, let me just erase this. If x minus 2 is my remainder, and this is a factor, that means that my remainder is going to give me 0. It's 0. Why? Because this is a factor. If it's a factor, my remainder is 0. So knowing that, I can solve for my value of a. So I'm just erasing this top part here, right? How much time do I have? Okay. We need to cut off on this, right? Knowing that f of 2 is going to give me 0, I can find my value of a. But how exactly do I do that? Well, f of minus 2, remember, when doing this, you substitute that value of x that you got into your polynomial expression. So wherever you see x, you're going to replace it with minus 2. What does that mean? That means that f of minus 2 is going to be 2 minus 2 cubed minus 3 minus 2 cubed, squared is going to cut off on us, yeah? But we can minus 4 minus 2 plus a. However, we know that this is going to be equal to 0. Why? Because the divisor that they gave us is a factor. Therefore, anyways, therefore, this whole thing minus 3 minus 2 squared minus 4 times minus 2 plus a, that whole thing is going to be equal to 0. From there, I can solve my value of a. So just rejoin, yeah, because it's going to come off now. We have less than a minute.